Let us start with solving question number 39, that is test the convergence of a given series, that is n square upon 3 raised to the n. We can apply a ratio test here. We know that if xn is the nth term of positive term series and L is equal to limit of xn upon xn plus 1, that is ratio of nth term to the n plus 1 term, and here limit n tending to infinity. If L is greater than 1, then series is convergent. If L is less than 1, then series xn is divergent, and for L is equal to 1, test is inconclusive. Here nth term is n square upon 3 raised to the n plus 1th term becomes, if we replace n by n plus 1, then we will get n plus 1 term, that is n plus 1 square upon 3 raised to the n plus 1. So by ratio test, take L is equal to limit n tending to infinity xn upon xn plus 1. So this becomes limit n tending to infinity. Here xn is n square upon 3 raised to the n into 3 raised to the n plus 1 into n plus 1 square. So this is just by a by b upon c by d is equal to ad upon bc. So this is the simple formula. So this can be written as limit n tending to infinity n square upon n plus 1 whole square into 3 raised to the n into 3 upon 3 raised to the n. This is just by rules of indices. So 3 raised to the n, 3 raised to the n get cancelled. So we can take 3 as a common, as 3 is constant. So remaining part is n upon n plus 1 to the whole square. So this is 3 into limit n tending to infinity 1 upon 1 plus 1 by n square. So this is 3. So this limit is greater than 1. So we know that if in ratio test, if limit is greater than 1, then series is convergent. So this implies our series is convergent. Next question, that is question number 40. We have to check the convergence of n square upon n factorial. Similarly, we can use a ratio test here. Nth term, we can take nth term is n square upon n factorial. If we replace n by n plus 1, then we will get n plus 1th term. So this becomes n plus n get converted into n plus 1. So take L is equal to limit n tending to infinity ratio of nth term to the n plus 1th term. So this becomes limit n tending to infinity xn is n square upon n factorial, and n plus 1th term is n plus 1 factorial upon n plus 1 square. So this becomes limit n tending to infinity n square upon n plus 1 whole square into n plus 1 factorial upon n factorial. So this is limit n tending to infinity. This can be written as n upon n plus 1 square into n plus 1 factorial can be written as n factorial into n plus 1 upon n factorial. So n factorial get cancelled. So this can be written as limit n tending to infinity 1 plus 1 by n to the power 2 into n plus 1. Obviously limit of this is infinity, and we know that if limit is greater than 1, then series is convergent. Here limit is infinity, which is greater than 1. So this implies our series n square upon n factorial is convergent series. So this is actually a simple problem. So let us start with the next question, that is question number 41. In question number 41, we have to check the convergence of 3n minus 1 upon 2 raised to the n. Let us assume that this term is this is actually not assumption, this is actually a nth term. So we can find its n plus 1th term just by replacing n by n plus 1. So this becomes 2 raised to the n plus 1. So this is 3n plus 3 minus 1. So this becomes 2. This becomes 2 raised to the n into 2. So by ratio test, take L is equal to limit n tending to infinity xn upon xn plus 1. So this becomes limit n tending to infinity. Value of xn is 3n minus 1 upon 2 raised to the n. Xn plus 1 is 2 raised to the n into 2 upon 3n plus 2. So 2 raised to the n cancel. 2 is constant, so we can take it outside the limit. So limit become limit n tending to infinity. 2 into limit n tending to infinity. This can be written as n minus 1 by 3. 3 minus 1 by n upon 3 plus 2 by n. This is just by dividing numerator and denominator by n. If we put limit, then this becomes 2 into 3 by 3, so this is 1, so limit is 2. As limit is 2, which is greater than 1, we know that if in the ratio test limit is greater than 1, then our series is conversion. This implies this our series is conversion. Next question, that is question number 42. Our question number 42 is a test the convergence of 1 upon n factorial. Here nth term is 1 upon n factorial. Take n plus 1th term. N plus 1th term is 1 upon n plus 1 factorial. So by ratio test, just take the ratio of n term to the n plus 1 term. So this is xn upon xn plus 1. So this is limit n tending to infinity. Xn is 1 upon n factorial. And xn plus 1 is n plus 1 factorial. So this becomes limit n tending to infinity. N plus 1 factorial can be written as n factorial into n plus 1 upon n factorial, n factorial, n factorial, it get cancel. As limit n tending to infinity, this is becomes infinity plus 1. So this is infinity, so which is greater than 1. Therefore this series is also conversion because our limit is greater than 1.